Okay, asante mfuatiliaji wa Jifunze Leo TV. Usikose kusubscribe channel hii ili uweze kupokea video nyingine zaidi na zaidi. Alama hii hapo nyekundu bonyeza, halafu alama ya kengele itatokeza, ibonyeze. Ukishaibonyeza tayari utaendelea kupokea matukio, utaendelea kupokea video kadha wa kadha. Mwanafunzi na mfuatiliaji wa Jifunze Leo channel, asante, karibu, endelea.
Ladies and gentlemen, my name is Sir Peter N. Ruvanda. I'm a graduate of the non-university in Tanzania known as Sokoine University of Agriculture. I have pursued Bachelor of Science with education in chemistry and biology, but formerly I was Songea Boys High School. I've been graduated from the combination of CBG. So I would like to invite you in this period of solving different questions of chemistry of advanced D level. Let us start with you, and then you can finalize with you. As you can see, ladies and gentlemen, there is a questions of 13 from the Necta of 2015. It is saying that, like the mechanism of the following substitution reaction, indicating clearly the nucleophile, substrate, and leaving group. As you can see this equation here. So now, first of all, what we have to know is this one, solution. So now, we can say that the first issue we have to know is to identify an electrophile and a nucleophile. Electrophile and a nucleophile before doing anything. So we have to do something known as the protonation. So we have the first step. So we have to have an electrophile and a nucleophile. By doing what? By doing the process known as protonation. So we have to take this sodium hydroxide, then split it into ions. The ions we are going to have is sodium ions plus hydroxyl ions. This is a nucleophile, and this is the electrophile. Nucleophile, electrophile. So after getting this, these ions, which is positive ions and the negative ions, this is the first step during mechanism. Then it comes to the second step. The second step, we are saying that we have to do something known as nucleophile attack. Nucleophile attack to the haloalkene. I think you can know. You can see here we have an haloalkane. This is the haloalkane. So now the second step we have to do this nucleophile to attack any haloalkane. How can attack? So we have to consider. So here now, nucleophile attack. Nucleophile to do nucleophile attack on the haloalkene, not alkene, haloalkane. So our nucleophile, I think we know exactly that it is an hydroxyl ions. So now these ions should be attached to the haloalkane. Our haloalkane, we have it. When I'm speaking about the haloalkane, means the alkane which is substituted with an halogen. So our haloalkane is carbon 83, carbon 33, and bromine, which is a halogen. It is halogen. So now has been attached in the haloalkane. So now, first of all, I think we have been said that we have to this nucleophile OH to attach in this. So we have to form carbocation first in order for this OH to come to attack to that carbocation which have already formed after protonation. So here now, because the reaction, of course, it is going to be taking place in here bromine. So we have to consider the one issue. We have to consider carbon and bromine, which is most electronegative. So we found that bromine and carbon, bromine is the most electronegative. And if bromine is the most electronegative, when we are blocking the bond during bond cleavage, so we have to break this bond toward the most electronegative element. So here now we shall break this bond toward this direction. Yeah, right now. So now after breaking this bond toward this direction, we have a carbonic cation and this nucleophile. So we have the following something. So now here we shall have CH3. Again we shall have C. Now here CH3. Yeah, CH3. Again we shall have here CH3. CH3 here. CH3. But here now it is a positive charge. And the one which is leaving group, bromine, will have now the bond attached between the carbon and the bromine has already been broken down. So now we form this carbocation plus bromine, which is negative in charge. Yeah, we have this carbocation, but also this bromine, which is a leaving group, is a good leaving group. Okay. After that, then he coming to another step, which is nucleophile attack. So we take this carbonic cation, so coming here, CH3. See, when this is arranged in a good manner, so we found that here now CH3, here now H, but here there is a carbocation. So U plus with O with OH, which is a nucleophile. So this nucleophile it is coming here to form a bond again. But remember that when this coming in this position, they tend to formulate another bond. But we have a bromine which has already left from the carbocation. So we shall find that we have the following chemical formula. The chemical formula we shall going to have here is this one: CH3, CH3, and hydrogen. Then here now you place this hydroxyl group or hydroxyl ions coming to this positive and the negative formulate a new bond. So now you found that here now OH. So after getting this, then you replace with bromine negative, like this. This is not positive, my friend. This is negative. Yeah, this is negative, and this is negative also. Bromine. Yeah, this is negative, negative, negative. Okay. So now after we have already formed this an alcohol. This is an alcohol plus this one. So coming to the third step, which is the last step, and the last step, the last step we are saying that is third step. Yeah, third step. Then we shall take the electrophile produced in the first step, which is sodium ions. Then we plus with bromine, which is negative charge or ions. Then we shall have sodium bromine. So now, after getting this one, so we have to consider two things by finalizing that we have already formed CH3, CH3. Then H, then OH plus sodium bromine. So by concluding, we can say that the reaction mechanism has already done here. So now, by concluding, we can conclude by saying that CH3 bracket 2 carbon CH3 bromine plus sodium hydroxide can produce the thing what we have already formulated here, which is the alcohol and the sodium bromine. So now you will get this CH3 CH3 and H, which is an alcohol, plus sodium bromide. Now this is our conclusion. Yeah, starting here, finishing here. So now this is our conclusion in the questions what we have already asked you to do, which is a reaction mechanism. Our questions asked us to indicate the nucleophile, substrate, and the leaving group. So now the good leaving group from our questions, the good leaving group is the good leaving group is bromide, which is negative in charge. Bromide, because it is the most electronegative compared to that of carbon. That's why it is good in leaving group. So our substrate here, our substrate according to our questions will be our substrate now will be our substrate will be CH3 bracket 2, then CH bromine. This is our substrate. But the nucleophile according to our question, nucleophile will be OH, which is negative in charge. I think we have already done these questions, which is the part A. So going to part B. Okay, so ladies and gentlemen, we are continuing with our questions in part B. Carry out the following conversion. Roman 1, propane to 1 chloropropane. First of all, you have to know the properties of alkane when react with the chloride. When propane react with the chloride under UV, sometimes tend to produce chloroalkane. So now here propane it's homologous series would be C3H8. This is now our hydrocarbons formula. Then now this will react with the chloride and UV. When I'm speaking about UV, I'm talking about ultraviolet rays. So under ultraviolet rays, so you at the end of this process you will have what you call 1 chloropropane. Our 1 chloropropane will be like as follows: C3 reaction now will take place here because the chlorine tend to replace hydrogen and form hydrochloric acid. So now here 1 hydrogen will be removed, then taken with the chlorine to form hydrochloric acid. So now hydrogen, 1 hydrogen get reduced, then it remains 7. Then chlorine take the chance of that hydrogen leaving. So now will be chloride plus the hydrogen leaved tend to combine with the remaining chlorine here, then form hydrogen chlorine. Our first chloropropane is this one. Now the conversion is over. So here now, this is part B, Roman 1, part B Roman 1. Then coming to Roman 2. Our Roman 2, our conversion is talking about to convert propane propene. Yeah, of course to propene, meaning that to convert alkane into alkene. So what we have to consider here, the same process would have been done here. We are going to be we are going to apply the same condition at the first step. So we have to write the hydrocarbons formula here, which we are saying that is the condensed structure, because we have got two types of structure. We have an open structure, but also condensed structure. But we do prefer on using condensed structure. So now here we shall have C3 H8. Then this one convert into, we have to convert into C3H6. So what we have to do here, it is very impossible to convert this one directly to this one. We must follow two steps. The first step, we have to take this alkane, which is the propane, then making reactions with the chloride and the UV again. So here take, when we do such kind of fish, we shall get something known as alkyl halide. Yeah, alkyl halide. So now reaction with the chloride gas and ultraviolet ray again, UV. So now we shall end forming with carbon 3 hydrogen 7 chloride. Yeah, so we shall have this one, carbon 3 H7 chloride. So after doing this, then we have to remove these halogens by reacting with the potassium hydroxide under alcoholic condition. So the second step here, we shall making reaction with this with potassium hydroxide and alcoholic condition. So now you will, and the result what will be happen is this: chlorine will return to react with this potassium. Then you will form potassium chloride. Then here now a single hydrogen will be removed here. Then remain with 6 hydrogen. The hydrogen removed here, we are going to react with OH to form water. So now we shall have an alkene. Our alkene is this one, which is what we call propene. So now our mechanism consists of 2 steps. Now here will be end of the sport, will be end of the game. Yeah, about part 2. Which is saying that complete the following reaction and name the organic product formed. Roman 1, we have this alkyne, as you can see, alkyne plus chloride gas and Lewis acid, aluminium trichloride, Lewis acid. So now we found that the Lewis acid will force this alkyne to go to produce something known as vicinal compound. Vicinal compound, the compound what you are going to see here. So now here, because we are not showing the mechanism, so we are going directly. Once chlorine want to attack any carbon, given that you have a triple bond like this, so once chlorine attack to the carbon, must break a single bond. Once one attack to the carbon, break the bond. After coming to another bond, then another carbon, then break the next bond up to the alkane. So now, what will happen here? What will happen here is like the following. Now, here now the bond being broken, first bond, so get carbon, then here chlorine, and chlorine again come here, chlorine, then single bond, then coming to another chlorine, carbon, chlorine here, so hydrogen. So now this is what we call the vicinal compound. A vicinal compound
a vicinal compound. So now in its nomenclature we can name it as because the question needs us to provide the name. So we can name it as because chlorine, this 1, 2, chlorine is located the first carbon. So we can say 1, 1, because we have 2 chlorine at the first carbon. Then coming to the second carbon, we have 2 chlorine, the second carbon. So coming to 2, 2, then we have how many chlorine here? We have only 1, 2, 3, 4. So we have 4 chlorine. So now we can say tetrachloroethane. So now here you have laid down about the vicinal compound. We have 1, 2, 3, 4. We call it tetra, but chlorine it is chloro, and this carbon skeleton or carbon chain we have 1, 2 ethane. So now this is the nomenclature of this vicinal compound. So this is Roman 1. Come to Roman 2, which is saying as hydrogen carbon, triple bond, which is alkyl carbon, single bond CH3. Then the condition what have been provided here, you have provided with dilute sulfuric acid. Dilute sulfuric acid. You have been given dilute sulfuric acid. And you have also given another condition which is mercury sulfate. Mercury sulfate at 60 degrees of centigrade. So what are going to be happening here? Its product is the product will produce something known as eno, and that eno, when rearranged in the second step, we're going to produce what you call an alcohol. So the first step we are going to produce an eno, but eno should become rearranged to produce an alcohol, which we call it propana. Yeah, it is propana. Let us work upon this issue. So now we shall have hydrogen, then carbon or H, which is eno, alcohol, then alcohol which is mixed with alkene, then carbon, then we shall have hydrogen. After there, carbon again, then hydrogen. After that, hydrogen. This product you can see here, this one, we call it eno. This is eno. This is eno. Meaning that we have an alkene, at the same time we have also OH. But this one, when you rearrange it in a good manner, so you will find that here now an equilibrium sign being established there, then you will form something known as propana. This propana will be H, carbon, double bond, oxygen, like this one, oxygen, it is double bond, coming to another carbon, like this. This carbon will have here now hydrogen, here hydrogen, but also carbon, then hydrogen, here now hydrogen. Okay, now this one you can see right now, we call it propana. This is nomenclature of this issue. We call it propana. Yeah, propana. Now this is end of the game concerning Roman 2. Come to Roman 3, about the questions from part C, which is CH triple bond C, sodium plus CH3 iodine or iodide. So now we found the following issue here, and this sometimes the reaction will occur here because this is an of course it is an alkyne. It is an alkyne, but we have sodium here, and we have an iodine. So this sodium will be good leaving group. So now will be terminated out. After we have already terminated, it is going to react with an iodine, which is negative charge, a nucleophile, but also this is an electrophile. So electrophile tend to react with the nucleophile. Yeah, maybe let me try to trace you back about the following issue before I'm not doing anything. It is of course electrophile cannot react with electrophile. So when you find electrophile react with electrophile, no reaction. But also the same when you find nucleophile react with nucleophile, no reaction. So we have to, the reaction can take place only and only if sodium maybe electrophile reacting with the nucleophile, like what we are going to do here. This is an electrophile, this is a nucleophile. So now sodium will be terminated out. After this termination, then this will come to react with this one. So we shall form this one form a bond with this terminal carbon here. So now we shall have CH triple bond C. Then this one coming to this chain, forming a longest chain, or we call it carbon skeleton, CH3 plus sodium react with iodine. Then you get sodium iodide. Yeah, sodium iodide. Then coming to the nomenclature of this one. So the nomenclature of this, we have to look for a longest chain. So when we come to the longest chain, we have to start in this side because it is near with the functional group, which is a triple bond. It is highly strictly prohibited that to start the place where it's very which is very longer to the position to the place where there is a functional group. So you have to start numbering from the region which is nearby the functional group. So now here we shall start numbering from left to right. 1, 2, 3. So we found that this functional group is in the first carbon. So the longest chain is what? The longest chain is 1, 2, 3. So if it is 1, 2, 3, now we shall say that it is plop. It is plop. Of course it is it is plop. Yeah, it is plop. Then a hyphen. Then coming to the position of functional group, which is in the first carbon. So we shall write 1 hyphen. Then the suffix y. The suffix y. Now here, this is the nomenclature of this compound form, or our product form. But we have also sodium iodide. So now, by making something good, you can say also this one is the sodium iodide. You write here sodium iodide. But the question of interest is this one. Plop 1 y. So now here it is end of the spot. Let us finalize by having a look on the 4 Roman, which is CH2 double bond CH2 and aqueous potassium permanganate, potassium permanganate and OH. So now let us trace back on the following issue. You know, potassium hydroxide is a strong oxidizing agent. So in any circumstance, in any scenario, potassium permanganate tend to oxidize this alkene. So this alkene will be oxidized. After the oxidation process occurred, we expect it to have dio at the end of the spot. So we have to formulate what we call dio. And mind you that this reaction have no mechanism at all. So we found that maybe alkene reacts with potassium permanganate, no mechanism. Alkene reacts with an ozone, call it ozonolysis, no reaction. So now coming here. So what will happen here now? Because no mechanism at all. Even if you go, maybe the chemist found maybe at Europe and whatever, are you packing? No anybody will show this mechanism. No anyone. So have got no mechanism. So what will be done here now? So this bond will be broken down. The issue what will be produced here. It is carbon, then O, then O, then OH. After that, then here hydrogen, here hydrogen, here hydrogen, here hydrogen. So now this one we call it a diol. Why it is diol? Because we have an hydroxyl group, two hydroxyl group. This one. So we call it diol. So now by its nomenclature we can say this one is an ethane. Nomenclature is ethane, then hyphen 1 comma. It's located on the first carbon 1, but another one it is located in the second carbon. So comma 2. Then because we have one first hydroxyl group and second hydroxyl group, so we can say di. Oh, so now this is our nomenclature for the diol formed after the strong oxidizing agent from this alkane. So ladies and gentlemen, I can say this is the end of the question number 13 from the Nectar 2015. So I would like to say thank you so much for listening what I'm speaking, what I've been talking today. But keep on, continue watching different solvings what we'll be doing in the next video. Thank you so much.